Hi, everyone. Thank you so much for coming out. We're so excited to be hosting you here at the Snowflake office for Streamlit's first New York City meetup. So thank you for making out. I know it's kind of rainy out. Um, my name is Caroline Frasca, and I work on developer relations at Streamlit. I'm joined tonight by Tony Kipkenboy over there watching the door. He also is on the DevRels team at Streamlit. And we've got a really great lineup of speakers for you tonight. So we've got Charles Frye, who is an AI engineer at Modal Labs. We've got Albert Zhao with us here. If maybe, oh, there you are. Okay. Who is a developer advocate at AWS, focused on Bedrock and foundational models. We also have Brandon Duderstadt, I hope I said that right, who is the founder and CEO of Nomic AI. Finally, we have Abhi Saini right there, one of the original product managers at Streamlit and a senior PM at Snowflake focused on Streamlit and Snowflake. And then we also have Aish. Where are you? Oh, there's Aish. Aish is a business intelligence engineer at Snowflake. And each of our speakers tonight really brings a super unique perspective on the current AI landscape. So, to give you a little bit of a roadmap for the night, each of our speakers will give a pretty quick talk, share some slides, maybe a demo. And following the talks, we'll actually just open the floor for any Streamlit demos. So, anyone and everyone who has a Streamlit app you want to show off, we'd love to have you come down here. You can share your screen just by joining the Zoom link that's on the meetup page and give us a live demo. And then we will also open it up for if you're hiring in AI or in tech more generally. We'd love to have you raise your hand at that point in the night, share what roles you're hiring for so that folks can come and find you during the mingling and networking part of the night. And at that point, we'll just open up for networking. And we have the space until 9 p.m. So we'd love for you to stick around, hang out, eat some dumplings if there are any left, which it looks like maybe there aren't. But so please dig into the food, enjoy yourselves, and help me give a warm welcome to Charles Frye, who is going to be speaking about scaling serverless Streamlit services, which I just want to say is also a really good tongue twister. So thank you.
Do that just to keep people on their toes, you know? Uh, oh, thank you. Yes. People keep putting it on the internet for sale and then it gets removed for trademark infringement, but it shows back up again within a week. So, you're just gonna have to look up Rage Against the Machine Learning and hope that it currently is on like Redbubble or whatever. I don't know that they sell it. You know, I don't know if Tom Morello's got the t-shirt shop for it, but yeah. You could Venmo Tom Morello $2. I think that's still a security hole in Venmo where you can send total strangers $2 anytime. Yeah. So I wanted to talk about like an intersection of a couple of interesting technologies with Streamlit, in particular some stuff from Modal where I work, and how it can be used with Streamlit. So there we go. Yeah. So first, like what do I mean by serverless and why is this important? Why does this matter for folks using technologies like Streamlit? If you build you build a demo, you get it out there, you show it off at a meetup like this, you show it to your stakeholders, and it doesn't get used for a while, and then it might get used a bit. Like maybe this is the next week, the utilization of that application goes up. Maybe there's a couple of people looking at it, and then somebody shares it in a big meeting a week later, and all of a sudden there's like 10 times as many people looking at it as there is normally. And this basic resource utilization graph with these like jumps and dips, with these very spiky moments and these drops, unless you have a really big application, you're going to see resource utilization like this for basically like almost every aspect of your application, whether you're thinking about memory, whether you're thinking about networking, or number of users. You tend to see these kinds of highly variable highly variable resource utilization, much less than peak. And so the key idea of the like serverless approach to computing is to say there's lots of applications like this. if they all banded together and used the same pile of resources, the like law of large numbers would say that the resource utilization would flatten out at some much higher number, but it would be stable. So serverless providers like AWS with Lambda or Google with Cloud Functions can sort of get rid of this variability that makes it very hard to serve these applications. Because really, if you wanted to make sure to have if you had enough resources to run this application, you'd have to provision this much compute all the time, or this much memory, or this big of a hard drive, or whatever. So there's a great paper about this idea from the folks at Berkeley. You may have read Mate Zaharia's paper about cloud computing. This is a sequel to that by some other folks focused on serverless computing and why it's a good idea and where it's a good idea from a serious computer science professor perspective. So I think this is something like you want to be able to, for a large number of applications and a large number of application builders, you want a serverless approach to your resources. You want to, which means you want, from your perspective, it's like the resources are present when you need them. That's when you're paying for them. And they're gone when you don't need them. You're not paying for them. And so you want this for all the components of an application, which from a high level, it's like you need to store information, you need to compute on and manipulate information, and you need to get information in and out of computers. So you need to share it with people, or you need to like interact with the physical world to send a payment or launch the missiles or whatever. And there's a bunch of tools that make building all of those pieces easier, which is really nice for many of the applications that benefit from the serverless paradigm, because they may be smaller. It's like you may build hundreds of dashboards in a year if you're using Streamlit, because you can build them way faster. Whereas like an application developer, traditional application developer works on one application a year. And so there's a bunch of tools that make it fast and easy to use serverless infrastructure and to deliver these applications. So for storage, I'm going to show you serverless Postgres with Neon. And for compute, there's Modal, where I work. And then for I/O, for getting things in and out of your applications, there's Streamlit. So serverless storage with Neon, it's like their tagline is basically, it's just Postgres. It's Postgres, but the compute that does all of the operations in your database, as opposed to the storage, you only pay, it's only active when you need it, you only pay for it when you're using it. So the storage is like on disk, effectively, on big hard drives, on cloud storage. And then they rather than keeping stuff in RAM, they're doing like smart things again with that. Like they have all these resources because they're serving many applications, not just yours. They're doing smart things about what should hang out in memory just in case it needs to be used, et cetera. But roughly speaking, like they're keeping stuff on disk and then pulling it up. That might not be a great idea for the original applications of Postgres, a lot of OLTP applications, that would be bad, but a lot of things that people build with Streamlit are closer to analytical workloads, and you can tolerate a query latency of a few extra 100 milliseconds, which sounds insane to the type of people who worry about query plan optimization, but is totally fine if you are running an analysis that ends up in a report that takes a week to be analyzed by the business. And because it's just Postgres, hashtag, they even have support for vector indexing because it's been added to Postgres. So if you're interested in semantic search based off of vectors, you can get it in Neon. So, and there are many other things you can get from that connection. So Modal, company that I work at, is designed to run your code in the cloud, in particular Python code right now, and make it as easy and as seamless as possible. And so you only pay for memory and CPU when they're in use, and we rent you GPUs basically by the second. So that's much shorter than the 6-month contracts that you get from the major cloud providers. So we kind of rethought the container stack from the ground up to fit these data-intensive workloads that people want to run. Frequently, the sort of back-end components of your Streamlit app might need to train a new model, or might need to run on rerun an analysis from the beginning, a big batch workload. And so these are data-intensive workloads. They're frequently in Python. They like if you're interested in AI stuff, they might be GPU accelerated, and you can't attach a GPU to something like an AWS Lambda function. So it's this similar idea as those kinds of serverless functions, but like aimed at this new workload. And then I probably don't have to introduce Streamlit at the Streamlit meetup. But because this stack has a pretty strong Pythonic orientation, Streamlit helps you create dashboards for applications in pure Python. And because your script is run from top to bottom on each interaction, Streamlit apps are like kind of stateless. Like you maintain the session state, sure, but you have to architect your app in a way that is like approximately stateless, or that like carefully manages its state in a very direct way. And that maps really well onto serverless compute and serverless infrastructure, because you can't just like set up a machine, like configure a bunch of stuff, and then accumulate information slowly over time in memory. The way people tend to write a lot of things like web servers. And that makes them frequently a bad fit for serverless compute. But Streamlit actually is a great fit. Like maybe one of the main things people think of is like this direct integration with these popular Python data tools means you don't have to reinvent the wheel while you're building these applications. So I just wanted to show you a quick demo, a little text-to-SQL demo built on this stack that I call Hex, patent pending. So let's see. I think it's kind of a little, this can go a lot longer, but I'm just going to jump straight into it. So I'm just going to serve, maybe I'll just quickly show a little bit of code. So I'm going to focus a little bit on the like Modal component. Modal lets you define the environment in which your application runs in a Pythonic way. So we're building a container image here. We're mounting volumes and information on that container image. And then we're defining the kind of entry points or things we want to run inside of that, and exposing a web server port. So that's what all of this stuff is doing. It's like the equivalent of a bunch of other things you would need to do with like Docker commands that you would write into scripts, or things you would write in Docker files, but it's all here in Python. And so this creates a publicly accessible web server, including with like hot reloading, et cetera. And we just have this little decorator here is what is the main sort of connecting point between like Modal and Streamlit. It's like Streamlit says, I'm a web server. I listen and communicate on ports. Modal says, great, I know what a port is. I can connect that to everything else. So that has opened up. Let's look down here. So I ran a little development server with Modal Serve. You can also like deploy, you bring your own custom domain name, etc. So let's open this guy up here. All right, so you can see stuff happening over there. It's being spun up as I interact with it. So even a Modal Serve says, okay, I'm gonna like lay the groundwork, make sure the container image is built, make sure things are ready. And then like only once I interacted with it did the Streamlit actually run and the thing get started. So this little demo just is people have seen the like language models write SQL for you, make your job a lot easier. So that's what this is, but built with Modal to interact with OpenAI's models, and Neon Postgres to store the information as we're uploading it. So like if you wanted to do text to SQL and you have information that are in like pandas data frames or in CSV files, you have to like map that onto your SQL compatible infrastructure, and this app just does that for you. So let's grab a file here. I was looking at the Stack Overflow developer survey results, just under the 200 megabyte default Streamlit limit on file uploads. And you can get it to not cause any like slow event loops or any other problems. But it's a large enough data set for it to be interesting. There we go. It's been loaded. You may have seen some things running like connecting to database, like converting to SQL. All that stuff is being run on Modal, and my Streamlit app just needs to know how to like look up a function on Modal and provide it inputs. But importantly, my Streamlit app only needs like dependencies on Streamlit and maybe pandas and like just a little bit of the stack, but anything that I need like directly communicating with Postgres, like the like clients and drivers, for example, don't need to be local. They can be, you can maintain a separate environment for those pieces. If you're running, like if you were running your own language model, which you could totally do, I just didn't get it shipped by this evening. You would have a separate image for managing all of your CUDA nonsense and installing PyTorch and Xformers with the fast attention and all that stuff. And that would all live in a separate container. And so you can kind of like more effectively modularize the pieces of the apps that you're building. So anybody have a question about the Stack Overflow developer survey that might be answered by a SQL query? Okay, great. So the Stack Overflow developer survey goes out, like 90,000 people answer it, I think, and it's like, what programming languages do you like, and how long you've been programming? Yeah, Donnie.
Percentage of developers are coding in Rust professionally?
Great question. What percentage of devs are coding in Rust professionally? Great. And the nice thing about English instead of SQL is that you can just write percentage like that or percentage, and you don't have to care about which one it is, because GPT-4 or Llama 70B knows what you mean, and you can kind of relax. All right, so let's see. So waiting for it to go through. All right. I've executed the query, but it seems that there are no results returned for the percentage of developers coding in Rust professionally. That's what I've heard. It's like pretty much just a meme language on the internet. Just kidding, just kidding. I actually did ask a version of this query that, like a slightly similar query that worked, which is how many people want to use Rust. Let me try that. How many devs want to use Rust? Great. So yeah, at the back end there is LangChain is the where I got the SQL agent from. So it'll like run the query. It like knows to check the schema first, then try a query, then decide whether the query worked or not. Yeah, so that would be a great one. So we could actually see it if we went to my Langsmith dashboard. So they have a little this nice little dashboard here. Where you can like track your AI applications, like what's going on in there. So this one here, select count star from survey results public where AI tools interested in using I like Rust. Okay, yeah, that's not a great query. So yeah, so this actually segues into my next slide, which is, turns out actually delivering value with AI is hard. So there's a great blog post from Honeycomb about how they actually built a text to SQL converter for their particular product that goes into okay, how do you monitor these things? How do you improve them over time? And I think if I had taken some of their advice in putting this demo together, we would have had a higher query success rate. Yeah, turns out getting a demo that works on a few queries is easy. Getting a demo that works on arbitrary queries is hard. Great. Okay, so anyway, that's a stack. I think it's interesting. It can save you a lot of money if you're making lots of apps that have highly variable usage. It gets you access to Postgres compatible database. It gets you GPUs, and it gets you the fun and ease of use of Streamlit all in a single package. Time for questions? Just one, maybe? Oh yeah, you.
Does it have like a free tier of 6 months?
Oh yeah, that's a great. I should say this. Yeah, so the $30 a month of free compute. So that's about 12 hours of A100 80 GB time, and it's basically a free web server because we charge by the actual cycles in RAM. So that's a good way to try it out.
In case of your demo,
Mm-hmm.
you were able to measure how much computing power
Mm-hmm.
are you using?
Mm-hmm.
And like, for example, like if you were to sell this machine to a customer,
Mm-hmm.
why would you tell them use us instead of hosting on AWS, GCP, or whatever?
Oh, I see. Yeah.
And my other question is, where is Modal hosting their serverless thing?
Mm-hmm.
Is it in the US, GCP, Azure? I'm not sure.
Yeah. Yeah, no, great question. So I'll answer the second one first because it's easier. The second question was like, serverless just means that somebody else runs a server. So where are the servers? Yeah. So they're like, so one, we're like a layer on top of other clouds. So we have some GCP, some OCI, some AWS, and then they are like spread in a bunch of different regions around, like, and you can specify if you prefer a particular cloud provider, if you prefer a particular region, that gets you like more predictable performance. So then the first question was like, oh yeah, why would you say like, oh, use this service instead of hosting it in any of these number of other different ways? So yeah, so if you want it, let's say that demo was actually running a language model, a local language model. You needed to fine tune. You can't send stuff to OpenAI. You have to keep it closer. So if you wanted to have you wanted to run the new Databricks model, that you need 8 A100s probably to run that model, maybe 4. Like that server is going to cost you 500 bucks a day on AWS, más o menos, like 25 times 24. And it needs to be up all the time, even when people aren't interacting with it. So it's like if your application has those like spiky, bursty form of traffic, it's like a slam dunk. There are many different like patterns of traffic that can lead to the same win, but yeah, the sparse is the most straightforward one. And then also like some people like, I don't know, I went down the rabbit hole of like learning how to set up Kubernetes myself and like learning a bunch of stuff about Docker. Like I wish I could have that time back. And there like a lot of that is made simpler by using the SDK. Yeah. Mm-hmm. Mm-hmm.
First thing I hear is like, how much it cost?
Oh yeah.
Why should I choose this where we did something, I don't know.
Yeah.
GCP, use the serverless cloud run, or with this orchestrate, skip the Kubernetes and like AWS, Frye, servers.
Mm-hmm.
And I'm trying to understand. I'm not like I
Oh yeah. Mm-hmm. Yeah, I'm happy to go into greater detail on this offline. But yeah, we got a couple case studies, one from Suno, the AI music people. They talk about like how it saved them money and made things go faster. It's not an enterprise yet, but that'll at least answer some of your questions. And yeah. I don't know too long. I keep answering questions. Okay. Yeah. Yeah. So that's a pretty direct one. Yeah.
Like even the things that look serverless, like SageMaker endpoint, are not charged serverlessly. You pay for the entire time between the endpoint.
It's very expensive.
Yeah. Okay. I think I'm happy to answer people's questions offline. I think I've gone way over. Thanks a lot, everybody.
All right, good stuff. Thank you, Charles. And talking about AWS, our next speaker is, Albert Zhao. Welcome, Albert. Albert is going to show us an app, Streamlit app that uses Amazon Bedrock that allows you to switch between different models. And yeah, so take it over, Albert.
Thank you. How's it going, everyone? So I'm just going to put up this image of, it's not a Turing test, by the way. This is someone's dog that was fed into one of our image models and it popped out. I know a lot of PR and marketing lately has been trying to, especially if you're a tech CEO, you're trying to get your quarterly earnings call to put yourself next to NVIDIA. I think today the focus will be more where AWS is, particularly around AI and generative AI. We have our own models, but it's early days and we connect to other models, but what's like the real value prop there? I think also there's like a famous quote about marketing. It's like the um, creative interpretation of the truth. Well, today I'll give it to you real, and we'll talk a bit about what Bedrock is, but also thanks to Streamlit, we can invoke it without needing to spin up a ton of AWS services. If you do need AWS credits, do find me after though, because I feel that pain. So first, I'll talk real quickly what Bedrock is. Yeah, Bedrock is a managed service for AWS models and third-party models. But the thing is, you don't need us to invoke third-party models. You don't need us to invoke Claude. You don't need us to invoke Llama. You can self-host Llama and run it yourself and save a ton of money. The thing about Bedrock is we partner with the actual model providers like Anthropic and Llama and Mistral. They give us a copy of the actual code of how the model runs, and we self-host it completely. And the reason why this is important is because AI model companies are going to be so many great models to choose from, but you kind of wonder, are they holding up to their promise? Or they're not training on your data? Claude emphasizes don't train on user input, and I feel inclined to believe them, but there's nothing safer than just like self-hosting your own model. And one way we can do this is you run it on our infra, and the next step afterwards is you start having some cost optimizations. But today we have some like really good speakers here. We're actually going to talk about like the science LLMs. I'm just going to kind of show you what Bedrock kind of looks like. So first, we're going to kind of just run this Streamlit app where you can kind of compare two models we have here. And because it's using Bedrock, it's legally compliant even for me to put company info in here. But we're just going to take something pretty simple as a prompt to kind of show performance, right? So we'll do something simple where we just ask a prompt of like, what is 2 + 2 equal to? And I think it's kind of interesting where you see the self-hosting really kick in here. All right, so on Claude, it took 1.24 seconds. And here, with our own model, it took like 20% less. But the thing is, the moment we started adding longer prompts into it, we really start spinning our gears a bit. So like, what's a good one? Like write a haiku about a cat. And let's output it into JSON. Thank you. Okay, Claude, it took 2 seconds. Now let's use a much newer, smaller model that we built. It took longer, and I'm not even sure it fits the haiku formula correctly, but it's weird. So then let's try it in Spanish. It's starting to hallucinate a little bit. Claude. I only took elementary school Spanish, but that feels right. And kind of over here, when we self-host the models themselves, you really start to get into nice territory where you can now just focus not on the security issues of, is user input being cached in a machine somewhere? You control where that is. And so this is the Bedrock playground. And My job at AWS isn't actually to go ahead and try to sell people on what we're building. I actually just do a lot of the launch behind the scenes kind of work. And one thing that we're really happy with is you can compare models directly on the Bedrock console. And if you use AWS before, we don't have a console that's quite updated in quite some time. With Bedrock, we're actually using a new design system that's open source called Cloudscape. And over here, we can really start comparing different models and also getting a sense like what are scenarios where it'll hallucinate. I will just kind of pause there because I don't want to be redundant, but any questions? Sweet. Yeah. Yeah, it's a great question. So Bedrock has several APIs where you can start fine-tuning the model, and you just hook it up to, like, say, an S3 bucket. And we're seeing customers now take things that you usually would have a human do, or it would require SageMaker and a ton of infrastructure, but now you can just feed data into Bedrock, which will call the model. And let's say like you have a mountain of PDFs and their invoices, and your CFO hired someone to be like, tell us anything that cost over $2,000 last year. You can now just feed that into Claude, and you can use Amazon Text Track to add XML tags to really optimize the prompt, and then you get that data right away. So that's what we're starting to see here with kind of, like you said, training on your own data, but also you can use more complicated data sources now to push through.
Thank you, Albert. And next, I'm going to welcome the CEO and founder of Nomic AI, Brandon Duderstadt. I hope I got your name right. All right. All right.
Hey everyone, how we doing? Cool. So today I'm going to be talking to you a lot about embeddings. Just by show of hands, who in the room knows what an embedding is? Love that. Who here is running embeddings in production? You'll get there, don't worry. Still a good number of you though. So today I'm going to talk to you about Nomic Embed. This is an open source, open weights, open data, what Amjad from Replit might call truly open source model that we released on February 1st. And it's the first truly open source model in the world to actually beat OpenAI's Ada and Text Embedding 3 on MTEB and Loco, which are short and long context benchmarks, respectively. And we thought that was pretty neat. And just as a fun fact, someone else today thought it was really neat on the front page of Hacker News, and actually used Nomic Embed and Atlas, which is a tool I'll be showing you later. It's this thing right here, to take a look at the OpenAI community forum posts. So if you too want to be on the front page of Hacker News and have me talk about you at a meetup, you should go use Nomic Embed. Where can you get it? You can get it on Hugging Face. This is actually an updated version of the model that we released a couple of days later called Nomic Embed Text v1.5. And this model supports a couple of things. One of them is something called Matryoshka embeddings. This is something that OpenAI's models support, and it gives you the ability to resize the dimensionality of your embedding space. So if you have, say, an output that might be 768 dimensions, but you're trying to store that and it's getting quite expensive, you can actually chop it down so it's only maybe 128 dimensions. And that's all well and good. And it also beats all the rest of the OpenAI stuff on MTEB and Loco and whatnot. But we could get cooler. So on March 18th, really recently, Nils from Cohere introduced Cohere Embed v3, which has support for something called a binary embedding. This is an embedding where instead of every dimension of your embedding being an FP32, so taking up 32 bits of memory, it's actually just a single bit. It's 0 or 1. It's binary. And that reduces the cost of your disk spend by like 100x roughly, which is pretty great if you're embedding and processing embeddings at scale. But little did Nils know that Nomic Embed 1.5 actually had been supporting binary embeddings since launch about 3 weeks earlier. All you have to do is take the output and go greater than 0, and you'll maintain 90% of the MTEB performance. Now you might be asking yourself, how can we compare these two embedding models, the floating point 32 one and the binary one. You know, you can benchmark it, which is interesting, but perhaps there's systematic differences in the embedding models that the benchmarks aren't capturing. And what are they doing for data on my use case? Well, that's where our tool Atlas comes into play. So Atlas is you can think of it, if you're technical, as an embedding space visualizer. And if you're a little bit more on the business side of things, as we like to say, you can think of it as a way to explore massive unstructured data sets using your web browser. If you are a dimensionality reduction nerd, you can think of it as big clickable tsne as a service. So you basically upload either your data or your embeddings, and we'll give you a web link back to a big clickable tsne. And so this one happens to be on Wikipedia. So every one of these dots that you see on the screen is an article on Wikipedia, and 2 dots are close if they're about similar topics. So these ones are, you know, this is an EP by Twins. This is an American R&B music trio. So this is probably music up in this area. But one of the things that Atlas lets you do, which is a capability we've released recently, is actually start to compare embedding spaces. So what you're seeing on the screen is the output of the embeddings of Nomic embed v1. And we can actually look at how those embeddings change if you transition to Ada by OpenAI. And one of the things that we can start to identify immediately is that this cluster in the bottom right actually starts to break apart when we transition through the embedding spaces. So we will quickly isolate it with one hand on the trackpad. And you can sort of see how that cluster actually breaks apart. This means that each of these embedding models has a systematic difference in the way that they're considering articles similar or different. The next natural question is, what makes them so different? So we can go and actually start exploring these articles. And what we start to see when we look at the text as we page through them, we get Richard Harrison may refer to, we get Whitney may refer to, NES is commonly used as an abbreviation, Bordija may refer to. And so what we can start to infer from this is that the Nomic embed model is treating disambiguations systematically differently than the OpenAI model. What we found is the Nomic embed model tends to group them together in vector space, whereas the OpenAI model actually tends to try and put them in, you know, categories with the thing that is perhaps the most related or their most common usage. And so, you know, these are just differences. They're not going to be captured in a benchmark, but you have to think to yourselves, for my application, which one might be useful? If you're building a disambiguation classifier, there's an obvious choice here. Another thing that we can look at is, so this is another map of AG News, which is just like a data set you can get on Hugging Face. And this one we've gone through and we've actually generated some topics on top of it. This is something that happens automatically in the Atlas platform. So you can upload your raw text and we'll give you a topic model over it that you can explore. And we can take a look at the difference between our FP32 embedding space and our binary embedding space. And we can do that using this position mode. And we can go ahead and just flip between the two. Let me turn the labels off. And we can start to see, you know, on the outset, there might look like there are some pretty large differences. You know, we've got some stuff moving around all over the place. However, one of the things that we can start to notice and think about as, you know, we try and parse out what happens in embedding space is whether these differences are kind of meaningful or different or what might be happening here. And one of the things that we have sort of come to realize at Nomic as we've studied a lot of these maps is the way that these embedding spaces tend to get built up is they recursively partition subspaces. And these recursively partitioned subspaces have a couple of properties. One is they're all approximately orthogonal. So you can think of the neural net training process as building up these high signal subspaces. And then at the next sort of iteration of evolution, building up another high signal subspace that's orthogonal to the first one. And this is actually, if we have any Chrysola fans in the room, this is supported by some of the toy models of superposition work coming out of Anthropic on the theoretical side. So we see it empirically is what I'm trying to say here. And it turns out that if we go into this map and we start to color by label, we see that we get a rotation between these two things occurring in sort of within label categories. And so what this tells us is, yes, okay, there's a difference between these embedding spaces. Perhaps it's a difference in the projection, but the difference that we're seeing primarily manifests within the subspaces that correspond to particular labels. So each of these models might be equally good for, say, a classification problem. The other thing that we see is if we go and filter down on, say, we call it the neighbor overlap score. You can think of this as the percentage of the top K neighbors that are the same between two embedding spaces per point, and we filter down to the ones with the lowest scores. We see that they're pretty uniformly distributed throughout the embedding space, which means that there's not really a systematic difference in errors between the higher and the lower dimensional models. So this is a quick sort of run through of some of the power that you can, enable yourself to have with Atlas, maneuvering through embedding spaces, starting to reason about them, also shameless advertisement for Nomic Embed. The last thing I'm going to show you guys today is something from an emerging product from Nomic called Data Streams. This tool tries to make it easy for anyone to get up-to-date data from relevant data sources in the world. And so we're actually going to look at a sample of about 1 million TikToks that we took today. And so suddenly you can start to go through, and we think it's really fun to kind of just fly around on this and see what people think about on TikTok. But one of my favorite things to do on this map is actually look at the create times of things and try to make inferences about culture and trends from it. So one of the first things we can see is if you watch this area right here, as I kind of scrub the time slider back and forth, we see there's this massive sort of bubble up in activity. And as we scroll into that area, what we'll find is that these all end up actually being TikToks about, what is it, Princess something, and I guess she's got cancer, which is quite sad, and this news broke recently. So, yeah, that's, just one of these trends that has sort of popped up on TikTok as a result of, as a result of something entering, some news entering the mainstream. And another thing on this map that I thought was super interesting actually happens down here. So what we see is we've got this football cluster of kind of like football TikToks and activity. And then over time, as the Super Bowl occurs, we see all of the sort of like attention space of TikTok getting like sucked into the Super Bowl. So like general football activity drops, but like attention to the Super Bowl topic really spikes. And then after the Super Bowl, it kind of goes back. And so you can start to parse out these really interesting trends in your query streams, either ones that are, from TikTok or ones that might be your production application query streams by running around on the map, categorizing it and starting to look at, what topics are kind of rising and falling. So I'll pause there. Happy to take questions now or happy to take questions after.
Yeah, sorry if you mentioned that, but for the labeling of the topic, how these selected basically? Is it topic modeling?
Yeah, so we use a topic model and we use some techniques from auto interpretability. So basically we take a bunch of different exemplars from the topic that we get, and then we feed it to a neural network, and we ask it to sort of summarize those exemplars. This is also techniques that you'll find in the work of Chris Olah out of Anthropic. Please go look at his lab, he's really cool. And one thing I didn't mention that I should have mentioned and forgot is what happens when you get a bad topic. So I actually made this topic bad sort of on purpose to demo this. You can actually go in and click on topics and edit them, and you can see things like keywords in the cluster. And so if you're exploring the map and you see something has got an incorrect topic, you can go in and see, okay, yes, this cluster contains, true crime as a keyword, and it might be first, but it also contains words like royal family and Kate Middleton and, podcast and Prince William and royals and murder. Oh, that's weird. But we can go in and we can maybe say Kate's medicine, we'll say. I don't really want to say Kate cancer. Kind of sad. And we can just go ahead and save that topic. And now, we've kind of updated that on the map. And one of the things that Atlas provides is a Python API where all of the actions and information on the map propagate into a database that you can access. So if I change that topic or say I add a tag to this set of data, say I don't know, this or some relevant set, you can sort of tag that subset of data and then immediately in Python pull out that set of data for sort of further downstream analysis. So there you go. So this is a data set that is actually provided through the Nomic platform. This is what we call the TikTok data stream. And effectively what we have got is some agents that go and run around the internet and try to collect data targeted to certain topics on certain platforms. And our goal with this is trying to make data sets of cultural importance or relevance available to researchers, as widely as possible. The tagline of Nomic is explainable and accessible AI. And it's definitely a company that thinks a lot about the impact that AI is going to have in the world. And one of the things that most concerns me is that, one, the internet's going to become increasingly shut down as companies realize the value of their data to AGI companies. And two, the internet's going to increasingly have fake content that is generated by the increasingly good generative models. And this is setting the stage for sort of a disaster in the public opinion sphere as fake content flies onto the internet and researchers that maybe research, I don't know, disinformation can't get their hands on it. And so we're trying to do something about that. Yeah, so TikTok, actually, we took quite a bit of time working on this. And one of the things that we've had to jump through from a hoop standpoint is making sure it was legal. And so we've actually had our lawyers bless this. So everything we are doing here is legal, or so they say. And we would love to try and open up more data streams, but there are increasing numbers of legal challenges in doing so. But if you're interested in getting access to the data stream, see me after. I'll get your email and we can try and get it in your hands. Yeah, so it is kind of a cat and mouse game. But I think we've gotten pretty sophisticated with the way that the agents that we have are actually kind of like running around and understanding web pages. And so far, it's been pretty stable, knock on wood. Yeah, so I'd say it's relatively stable right now. Yeah, so I actually have some maps I can show you on this, which are really interesting. And so we're going to go off script here for a second. Also, I'm also taking up a bunch of time, so I don't know who else is left to present or if I need to stop or something. Okay, yeah, so this will be the last question. We'll see if I can find it real quick. You're going to see a bunch of... Oh, this might be on staging. It's going to take me a really long time to find this thing. But TLDR, this map happens to be embedded on the captions. The captions do a good job of capturing algorithmic bubbles in TikTok because they give you a signal about two things, the video description, as well as the hashtags in the video. And the TikTok recommendation algorithm is primarily based on hashtag co-occurrences. But we can also go in and embed the videos themselves, either with off-the-shelf video embedding models, or we're working on our own at Nomic that will hopefully open source at some point this year. Or you can do a joint embedding of them both. So you can just concatenate the two. And they each give different maps. And it's super interesting to see what things are close in video space and far in other spaces. One thing that's kind of hilarious is if you embed in audio space, you'll get a map that's based on like song trend. And so you'll get videos and captions that are very different, but you can watch how a song kind of like percolates in the different sub communities as it's blowing up. So cool. Yeah. Thanks.
Seems to be a lot of questions. Yeah, I just want to remind you all that after this, definitely you can mingle and ask more questions. And so we'll go to our next speaker, Abhi Saini. He's a senior product manager at Snowflake. And he's going to talk about how enterprises can build apps using Streamlit in Snowflake.
All right, thank you, Tony. Hello, everyone. It's great to see everyone show up today. And my name is Abhi. I'm a product manager on the Streamlit team at Snowflake. So I've been working on Streamlit for about, I guess, 3.5 years now. I spent time working on the open source side, the community cloud product, and now I work on Snowflake. So today I wanted to talk about why Streamlit on Snowflake makes sense. Why do enterprises want to run Streamlit apps, and what is different about the enterprise use case? Then I'll do a quick demo of Streamlit in Snowflake, which is the platform for deploying apps on Snowflake. And since LLMs are the flavor of the season, I have one demo as well. So Snowflake offers managed LLM services. We call that Snowflake Cortex. So I have a 35-line demo of building a chatbot using Cortex and Streamlit. Before I start, just a show of hands. How many of you all work with Snowflake at work or have used it before? Okay, cool. That's great. Good number. So for those of you who work with Snowflake, hopefully this is a refresher for everyone else. You can learn more about how things work inside Snowflake. So what are the considerations for enterprises when it comes to building Streamlit applications or any kind of data applications in an enterprise setting? So most companies have a lot of data and it's sensitive. All our IT teams are very paranoid about making sure that you have the right role and you can't access data which you're not authorized to access. So there's a lot of sensitive data, and we at enterprise companies want to make sure that that data is not flying around and there's secure access to that data. Secondly, companies care about business continuity. So if you have a Streamlit app that was built by, let's say, your IT team, and the entire company uses it, you can't be in a situation where suddenly the app goes down and now everyone is like looking around, what do I do? Because my workflow depended on that app. And then finally, these apps need to be scalable. These app needs to be performant. So every app is different. Maybe some app builder is running a machine learning model on an app, and that app might need a big compute setup, might need a lot of memory, and then someone else might be running a small 2-chart dashboard, which doesn't need a lot of compute power. So there was also the demo earlier on where there was a nice chart showing a traffic spike. So depending on who's using or how many people are using, the infrastructure should scale based on the demand, and app builders should have the control over changing the infrastructure size. So those are some of the considerations for enterprises. And what we have built in Snowflake is a fully managed deployment platform for Streamlit. So as the app builder, you don't have to worry at all about the underlying infrastructure. You don't need to worry about the compute, the storage. You don't need to worry about SSO. So those kind of things which have been, traditionally people have to build that themselves when using Streamlit. We want to do all that heavy lifting on the behalf of the developer. Next up, governance. If you're accessing an app, if you want to share your app with someone else, role-based access control and sharing the app with the person who only that person or that person holding that role should be able to access that app. So security and governance is critical. And then finally, we don't want data to egress or ingress from your data warehouse. Ideally, it's best if the apps live close to the data as much as possible. It's better from a security standpoint. There's less work involved in building pipelines or writing APIs to make that happen. So we believe that the data should live close to the app as much as possible. And just in terms of use cases, Streamlit is generally available on Snowflake, and we're seeing our customers do a lot with this product. So things like workflow monitoring, LLM apps, again, flavor of the season. People are building what-if analyses, monitoring tools within your company. Say you're an IT admin and you want to ingest a report and write that data back into Snowflake. We're seeing a lot of our customers build Streamlit app for those kinds of things. So it's empowering different personas within these companies to do more with their data and do all of that within the Snowflake ecosystem. So with that, let's do a quick demo. So I'm showing here the login page when you log into Snowflake. So you'll notice like all the apps that I already have are listed here. And then let's say I want to create an app. So creating an app it's fairly simple. You choose the location for the app. And I'm choosing my default warehouse, so this controls the compute. And I click create. And then this will place me in this side-by-side editor where I have my code on the left-hand side, and on the right-hand side, I see my app. So right away, like I didn't have to worry about any kind of infrastructure. And as an app builder, like I can focus on writing code as opposed to worrying about like, all those other things around infrastructure. So I'm here, I can change my app's code, click on run, and then the app changes right away. So you can see that side-by-side interface and see changes made to your app. And then let's go to another app. So I'm a product manager. I'm not a good coder, so I'm not going to be live coding. So I wrote some of the code before the demo. But I just want to quickly walk through and show how this works with Snowflake Cortex. So I'm importing this function called complete here at the top. And then I have some instructions to my LLM. I have a select box to choose which model I want to use. So I have Llama 2, Mixtral. And then the rest of the code is around like taking and storing the messages in session state, taking a prompt, and then collecting a response from the agent. So right now I'm using Llama 2. So let me just say hello to it. And it returns the response. So there's no provisioning needed for my LLM as well. Snowflake has provisioned it already for me, and I'm able to call that model and use it directly. So that is a quick demo from my side. And if you want to learn more about Streamlit and Snowflake, please go to snowflake.com/Streamlit. Yeah, it's great to meet everyone today. I'll be around if you have more questions. Yeah, I'll pass it back to Tony.
Cool demo so far, right? Yep, good stuff. So on to our last speaker for the night, Aish Shirahatti. She's a business intelligence engineer at Snowflake, and she's going to show us a demo of a Streamlit app. All right.
Mic here. Hey everyone, hope you all are doing well tonight. So yeah, as I was introduced, I'm a business intelligence engineer here at Snowflake, particularly on the marketing intelligence team. So lovely to see all the different Streamlit app demos tonight. This one won't be focused specifically on anything AI related, but more just how we are using Streamlit within Snowflake itself, more for the marketing subsection here. More specifically on website analytics. So I'm going to go ahead and demo the app here. I have also been dodging a software update for a long time, so if it keeps panning to another tab, please excuse that. So here we have the marketing website analytics app that I've built. So within the app, I think there's a couple of different layers depending on who your main audience would be. So when it comes to web analytics, you have the more high-level audiences, whether it's executives who are more interested in terms of just generally how we're tracking, or somebody more on our internal teams, whether they're handling like how specific campaigns are going, or how certain UTMs might be performing. And then finally, the lowest tier would be the more component analytics driven aspect. So this would be more of somebody on our web team seeing how certain content being switched out is affecting our website like tracking or anything like that. So those three layers are kind of built in here. So the first layer here is the actual high level website analytics. So we have a little bit of like a definition metric here and also some general updates. So if anybody's viewing the traffic, they can see kind of what might be affecting it and different factors that are known. So below here, tons of amazing Streamlit features in terms of visualizations. You can add your metric tabs at the top for any of your top line metrics, general charts, any kind of breakdowns. So what this really allows you to do is hone in on what your specific KPIs are and make sure those are kind of displayed at the forefront. And there's a lot of customizability when you build an in-house tool as opposed to using something that's already built out like Google Analytics or Heap when it comes to specific website tracking. Further, we have more of like a traffic breakdown, top pages, UTMs, etc. So these are kind of the functionalities we've been able to play with at the high level. Diving one layer further, we can go into page analytics. So in this section, I think I've worked more with the web team to kind of hone in on what are the areas they're more interested in. So if we were to go to snowflake.com here, we have tons of different kind of options available for the user to be going through, whether it's workloads or different kind of industries specifically. So for a web team, it's kind of a focus that they'd want to look into on how exactly each of these sections are tracking. So within the page analytics tab, we can go ahead and select maybe what kind of date breakdown we'd like. So if we wanted to see the quarter over quarter view, and look into maybe the past few quarters. Again, this is all dummy data for the sake of the presentation. And then go ahead and select, for example, if we're interested in workload specifically, we can go ahead and load that up here. Say we're interested specifically to see how our language content is performing. So what we've built in is a couple of dynamic breakdowns so we can see specifically on language or device type, how are users tracking? And one question somebody might have is, for example, within France, they're using French and English. So how well is that content tracking within that specific region? So we can go ahead and filter it by country. Go ahead and select France here. And then I'm hoping it loads relatively quickly. But through this, you'll be able to see more of the specifics in terms of page analytics or views or any of the metrics that we might be more interested in. And that way it'll kind of allow you to look into it at a more granular level. But while that's loading, as a raise of hands, who here is involved more in like a marketing-based function? Okay, so a couple of you, love to see it. Okay, so as that loads, it's tabulating essentially within the workloads feature of the website. How are we tracking? So we have breakdowns of page views, visitors, sessions. Oh, okay. Well, of course it's gonna go wrong while we're trying to demo something here. Maybe I think it could have been that we didn't have that feature or page live at certain times. So I'll go ahead and load the last 2 quarters of data here. Okay, well, there we go. Yeah, so this is also Streamlit in Snowflake. So yeah, we're building it in terms of like DBT and then deploying that. And then, yeah, it's being built with compute in Snowflake. Okay, so here we have our data loading, page views, visitors, sessions, etc. And then you can kind of customize what your specific KPIs are, see the breakdowns that we've selected above as well. And I think with web data, it's very vast in terms of just how much data is coming in. So in terms of the load time, fortunately, this is actually one of the faster ends in terms of web traffic. So yeah, that's what we're seeing here. And then we'll also see breakdowns specifically within the features that we've selected. So this would be language, device type, country being filtered as well. Okay, well, for the sake of time, I'm going to go ahead and move along while that's being loaded. But essentially, you can see different types of breakdowns according to what you'd like. And then we'll move along to component analytics, which is the most granular form. So we'll go ahead and load this on a week-over-week basis just to make it a little bit easier for us. Look into the past few weeks here. And on this section, we've kind of specified within a certain page component what are the specific breakdowns. So we have like customer cards on the website end or something that's more like a resource page. So we want to see how those are tracking. So for example, if I wanted to look into specifically maybe customer stories, which is a feature that our web team is trying to work on a little bit further, we'd go ahead and run the component analytics here. And we'd be able to see summary of activity, whether it's clicks based or how many content pieces are involved. And then also a breakdown of all the different components we have within that subset. So we can see how each of those are specifically tracking. So for example, when we switch out the content, we can see how it's been performing week on week. And if there's a certain one we want to be more like promoting a little bit more, see it's tracking a little bit better, that will also be embedded within that. But yes, that is kind of the general gist of website analytics. It's mainly an internal tool to allow us to be a little bit more granular with our web analytics function. But yeah, that should be everything. Thank you.
Thank you, Aish. All right. And let's give a round of applause for our speakers, first of all, because they did a great job. Awesome, great demos today. And before we get to welcome everybody else to demo the applications, if you have an app, please get ready. We're gonna get you up here, get you set up and share your demo. Before we do that, we usually like taking selfies on this meetup. So if everybody can come in a little bit, get closer, and we'll do a cheese, and then we'll take a selfie, group selfie. All right, let's get in, if you can. All right, 1, 2, 3, we're gonna take cheese, okay? On 3, 1, 2, 3, cheese. Oh no. All right, we'll take so many of them. All right, cool. Thank you all for participating in that. Yes, we will. Awesome. Cool. So the floor is open now. If you have a demo, please raise your hand. We'll get you set up here real quick. If you have a Streamlab demo that you want to demo. Yeah, so if you want to demo an app, please go to the Meetup page where you signed up, and there's a Zoom link there. You can enter that Zoom meeting and mute your mic, and then you'll just be ready when you come up here and do the demo.
All right, while we're working on that, I just wanted to share a free event that Snowflake is hosting this June on June 6th at the Moscone Center in San Francisco. It's part of our Summit conference. It's going to be a free full day developer conference. So I don't know if anyone here is actually from San Francisco or maybe you have friends there, but there's a QR code there. There's going to be some really epic talks and some Gen AI content. Some really great, a really great event. So definitely recommend checking it out. Scan the QR code there. Like I said, completely free, June 6th, San Francisco.
Hey everyone, my name is Aziz. I'm a data scientist based here in New York City. I've been using Streamlit for a while, ever since it came out, and I love it. It's one of my favorite things. So I've been using it pretty much like a Jupyter Notebook. So I kind of like gave up Jupyter Notebook. I started using Streamlit for almost everything. So recently I was like, what if we could use Streamlit just like Jupyter Notebook? So I built this simple app demo, and it's also available online here if you wanna give it a try at stbook.streamlit.com. So it's pretty much similar to the experience of Jupyter Notebook. You can use it just to add cells and run every cell individually. Like you could, yeah, like here. Sure, thank you. So every cell is really executable. So you can literally run it. And the cool thing, it's also like just like you can execute any Streamlit command here, literally just like Streamlit. And also, let's say if you want to file uploader, you can download like files from your system and work with them directly. There's also another demo that I just want to share also here, which is, this is a local demo. It's not deployed, but I use it to run things like RAG or also kind of online answer engine. So instead of like search engine, it's more like online answer engine. It's hooked to different LLMs like OpenAI LLMs and then Grok LLMs, the fast ones, also the Olama LLMs, the local one. The cool thing is about it is it's hooked like to online data, so I can get whenever I ask a question here, in the backend I will connect to the APIs here, Google, for example, DuckDuckGo, and this is one of the cool things, Tably AI. It will return images. So, for example, if I ask any live data, I would say, what is the weather in New York today? And here I'm using Mextro model, which is from Grok. It will get the images and yeah, it will tell the answer and also probably the links to more information about it. This one is actually more like under the hood look. So I will get all the the details about where the information came from. So for example, these are the document that the LLM used to get this information. And well, one last piece I want to show about this, I could use it also as a RAG. All of you probably know RAG. You could load local files or like load a web page. You just paste the URL here and the HTML page will be indexed. Or I could also do a web search. I can also hook it to an API. For example, here's Semantic Scholar and search any papers, and then there will be, here's the RAG database. It's all the document indexed here, and also I see a visualization of these, all the document kind of like indexed in that. That's pretty much it. Thank you.
Awesome. Thank you. I think we got the next presenter. All right, go on up.
Great. My name is George Krasinski, and I work with Justin Coe. We're undergraduate students at the Cooper Union, and we've developed an MVP demo product plugging regulatory data in from the FDA, specifically for good manufacturing practice consultants and other consultants in the quality regulatory space for pharmaceuticals. That's what we've done. We're looking for assistance and help building out our current Streamlit demo. You want to show them what we, yeah, so we've kind of assembled a table interface of regulatory data, and then further on, we've been able to segment that data by officers and by compliance violation codes. So it's simple in its current state, and we have trial users, and we're looking to build it out further. I don't want to take up any more time. Thank you.
Hey guys, my name is Joseph. Can you guys?
All right, so this is my first time demoing something I built, so exciting. Thanks. Couple of days back, a month back, my wife, she is on Instagram a lot. I'm also on Instagram a lot, but then she follows a lot of influencers. And she was like, hey, it would be cool if there would be if you can use AI to figure out what products were reviewed in Instagram content, right? Audio and video. I think Brandon earlier demoed how they made the TikTok graph. Similar concept, but then more like a product. I work in product, so I was like, okay, hey, maybe there's something here. So I put this thing together. So it's basically, there's no search on Instagram. So this helps you build a chatbot for an influencer. So I have a few ones over here as demos. The first one, it's called Hydration CEO. So she's an influencer. She has around maybe 162,000 followers. She posts about like things like shampoo, beauty products, and whatnot. So what happens is, let me click here. So you can see if I click on her Instagram, so she has a lot of content, and you can see how there's audio, video, and stuff in it about lip gloss, right? So she's reviewing lip gloss. And if you use the app, you can basically talk to her assistant and say, what is really good, or what lip gloss products do you recommend? And then it pops out like a chatbot link, what it suggests, as well as the recent links about lip gloss that she had put together. So this is just for one person, and then I've created something else for, this is like a fashion blogger person, and this is Marcus Brownlee. He does tech. So you can ask, oh, do you like the, Samsung Fold or the iPhone something, right? And it'll give you his opinions. So yeah, something I've been working on, still tweaking, my first time building something. So just thought I'd share here.
All right, thank you. So some awesome demos. I don't want to close out if there was anybody else that wanted to demo. Going once. I guess there was nobody else. Okay, great. Another round of applause. Great demos today, great presenters. Yeah, absolutely. This was awesome. And so this next segment now is if you're hiring, please raise your hand up. I can give you the mic so you can share what roles you're hiring for. And you can meet those people and mingle with after or during this networking session that's coming up. So I guess who's hiring? I'll bring the mic to you.
Hey everybody, my name is Mike. I'm from an analytics company called Quantigy Analytics. We're looking for data engineering roles and business intelligence analyst roles. And ideally, if you have both skill sets, that's great. Especially if you're looking for contract roles, part-time roles, or internships. If you're a student, we help set up modern business intelligence for a wide variety of companies. So think going from like total scratch to building out a whole modern tech stack, data stack. And we use Streamlit as part of our tech stack. So come chat if you're interested in finding out more.
Hey, yeah, so presented on Modal, we're building serverless infrastructure that doesn't suck. And we are hiring people who have a systems engineering background, worked in distributed systems, and if you're not afraid to do a little kernel level hacking to make people's functions boot faster, we'd love to talk.
I agree. I don't know if you all agree, but this was awesome. But so just to close out as well, this kind of closes out our formal programming for today. And so what happens next is we all get to mingle. This space is still open until 9. So please feel free to roam around, talk among each other, network, share contacts and things like that. And just want to encourage y'all to go ahead and check up meetup.com and look up Streamlit. We'll be hosting future events here in New York as well. So please stay tuned there. Keep your eye out there for our next event that we'll be hosting again. And with that, I just want to say thank you for coming. This was really awesome. And let's do this again.